For circuit 1B potentiometer, we have a new component. Guess what it is? Potentiometer. So this is what it looks like. It's this little blue device. It has 3 wires, 3 legs, and they connect to our positive, our ground, and analog input. So we are going to rewire our circuit a little bit. So notice that we are connecting our ground, and instead of having our ground from our LED directly go to our breadboard, it's going to this column here. Alright, so let's go ahead and set this up. So I'm going to start off by disconnecting my breadboard by unplugging this USB. Let's go ahead and work with our LED and rewire this black wire. Let's go here. I'm going to add another black wire to activate this ground column and connect that to my breadboard. Both of these grounds serve the same purpose, so it doesn't really matter which one you use. Now I'm going to provide some power to my breadboard by connecting my 5-volt pin on my breadboard, and that'll go to this column here to activate this entire column here. So now I'm going to go ahead and place my potentiometer, and this is going to go on column A, row 24. Followed by my blue wire. You can use a red or black as long as these items get connected, and this is going to analog 0. My black wire going to my ground, and remember this entire column is activated now that this pin is connected up here to our breadboard. And finally, we're going to connect our positive leg on our potentiometer to our positive column on the breadboard. That's pretty much it. Now that we have our board set up, we are ready to start uploading our code. You can either scroll down to find the section and copy the code, or you can hold Control, click F. This window pops up, and go ahead and type in copy code. So once you type that in, it'll take you to the actual location where that is read. So we have copy code. So let's go ahead and copy this code. Control A, delete, just to make sure everything's deleted, and paste my new code. So before you upload your code, make sure your board is connected. We have power. Now let's go ahead and check our tools. This is a breadboard, but on Arduino IDE, we're going to be clicking on the Arduino Uno. We see that our port is detected and that we're using this programmer. That's called Arduino ISP. So let's make sure we see our lights blinking, and if we have successful communication, our TX and RX lights will start blinking very quickly, and we have a successful upload. Perfect, we're done uploading. So our light is blinking just like normal. It blinks on for 1 second and it blinks off for another second. However, if I adjust this potentiometer, I am actually making the light blink faster and faster and faster, or I can make it blink slower and slower. Unlike circuit 1A, where we were actually manually inputting our speed by changing our delay, this potentiometer, however, is affecting the delay directly. Let's go over the code itself. Up above, we have a large comment that just describes where we're getting the code from. Shout out to SmartPhone for this code. So on line 14, integer pop position is just a word that stores a value. We'll get into this later. As your code becomes more complex and as you become a better programmer, you're going to start making more complex codes that use more inputs and more outputs. In another sense, you're going to be using more buttons, more switches that have controls over different objects. So in this case, we are going to be using integer pop position because that is the physical object that we are using. So we need to get in the habit of identifying the physical objects that we are using so we can go ahead and reference those objects in our code. So we'll leave this for now. We'll get back to this later. Void setup. This is where we're having our board communicate with our serial connection with the computer, and we'll explain how that works later. In addition, we have our pin mode. 13 output, so in this case we are sending electricity to our pin 13, which is connected directly to our LED. In void loop, we have the code that runs over and over again, and notice we have this new term, pop position from up above equals analog A0. Notice how our potentiometer is connected to analog input A0. Pop position will have and store the value that is read from analog read A0. And then serial print ln, this is a function which will print this value here, pop position. And remember, pop position is analog A0, so we're pretty much printing out whatever value we read from this blue cable that's connected to our potentiometer. For line 30, we have digital write 13 high, and in this situation, we're sending electricity to pin 13 and we turn on our LED. However, we turn it on for whatever value is stored for pop position. Remember, pop position equals analog read A0. or wherever this knob is at. Finally, we have digital write 13 low, and that turns off our LED because we stopped sending electricity to our LED. And in this situation, we keep that LED off for whatever position our potentiometer is at. So notice it's on and off for less time, so it makes it look like it's blinking really fast. And then as we turn up potentiometer, it has a slower rate of blinking. Okay, so let's take a step back. Let's actually go back to serial print LN pot position. This is line 27. So for line 27, you actually need to open up a new tool that you'll be using from now on. So let's go ahead and click on Tools and click on Serial Monitor. This serial monitor right here is what we're printing our values on. So remember, we have print LN, so we're printing a new line, and we are printing our value for potentiometer. So let's see what happens. So as I turn my potentiometer, my value decreases, and if you also notice, my LED is also blinking faster. So notice as that number decreases, my blinking rate increases, and as the number increases, the LED blinks slower. So please make sure you connect your SparkFun breadboard, and you select SparkFun breadboard if you're using an Arduino board. Make sure you select Arduino Uno, which is located here. You select the right port. You should have connected CodeBender by now, and make sure that you turn on your serial monitor for the circuit by clicking this, and make sure you connect and have this value here. Circuit, it is very important that you do read through the SparkFun Inventor's Kit Experiment Guide, and specifically this section here that explains the analog versus digital components. With the digital component, normally something is either on or off, and an analog component, we can have an infinite amount of possibilities as written here. An example of an analog and digital input would be a slide dimmer switch, where a switch is used to either turn lights on or off, but the dimmer is used to allow the light to vary its brightness depending upon the position of the dimmer itself. So we have a lot going on here in the screen. We have our circuit diagram, this chart, our serial monitor, and our actual circuit that's set up. As we turn this knob here, it affects the numbers that we see printed here on the screen, and it also affects the blinking. So the higher the number, the slower the blinking. The way that this is working is because we are using something called a variable resistor, or in this case, the potentiometer. We'll be working with various variable resistors in these projects, but for now, let's focus on the potentiometer. However, they all work the same way. They have 3 legs, or we create 3 legs out of them, and we have one leg connected to our ground. We have another leg connected to our 5 volt or our input voltage, and then our third leg, which is usually the middle leg, is being used to measure the varying voltage that is going through the circuit as we vary the resistance. So in this situation, we already have a fixed resistor here, but this one is specifically used to make sure that the LED doesn't blow up. The potentiometer is once again being used to vary the resistance, which varies the voltage, and then we can measure this difference in voltage, convert it to bytes, and then have a value per milliseconds and use that as a delay. Our maximum voltage is 5 volts, which corresponds to a maximum value of 1023 bytes, which is equal to 1023 milliseconds. So as you see on this screen here, our LED blinks on for 1 second, and then it turns off for 1 second. And that's because of this. However, if we rotate our dial halfway to about 500 bytes, which is shown here in this serial monitor, we notice that our LED starts blinking faster. So now I am around 500, and it's blinking at a rate of half a second. So this is pretty much saying that if we were to measure our voltage going across this potentiometer, which is here, we would get a value of 2.5 volts. Now in this situation, if we rotate our dial all the way down to 0 volts, notice our LED is on. Well, it's on because it's blinking very fast. So the closer we get to 0, the faster the LED blinks. So in the next few videos, we'll be going over the troubleshooting and the challenges for the circuit. Thank you for watching, and enjoy.